Welcome to Hidden Layers, where we explore the people and the technology behind artificial intelligence. I'm your host, Ron Green, and I'm delighted to have Paco Nathan joining me for a second time on Hidden Layers. Paco is an AI industry veteran with decades of experience, and today he's going to share his thoughts on areas of AI that he is particularly excited about, shine a light on areas that may not be getting enough attention, and share some of his thoughts on where he thinks AI might be going in the near future. Paco Nathan is managing partner at Derwen Inc, and author of Latent Space, along with other books, popular videos, and tutorials about machine learning, natural language, graph technologies, and related topics. He's known as a player coach with 40 plus years of tech industry experience, ranging from Bell Labs to early stage startups. Paco holds a BS in mathematical science and an MS in computer science, both from Stanford University. Paco, thank you so much for coming on again.
Thank you, Ron. So glad to be here.
All right, let's just jump right in. There's a ton of stuff going on in AI right now, more than any of us can keep up with. What are you particularly excited about these days?
Yeah, it is really hard to keep up on everything. I definitely, I dedicate a lot of time every morning to just reading the latest coming across. I think that right now what's happening, we've definitely seen a lot of marketing. Not to throw too much shade, but there are certain companies that are really good at marketing. They're also really good at AI, and they tend to use their marketing to talk about their AI. So I'm interested in the other voices, like what is not particularly coming from those particular bully pulpits. And I really am interested in what's happening, say, mathematically, for some analysis of this. So, for instance, I think that on a broader scale, when you look at any kind of like civilization-changing technology, any big technology shift, whether we're talking about the introduction of electrical power grids or nuclear weapons or commercial airframes, how they had to be totally redesigned in the 50s. Anytime there's a really complex kind of technology, you start out with something that's relatively ad hoc. It's like, wow, It's a breakthrough. It works. We're glad it works. We don't know why. And then the mathematicians show up a couple of years later. And mathematicians like to look at complex problems, and they like to understand risk because somebody's going to have a whole bunch of capital investment in infrastructure if it's civilization changing. And you need to quantify risk if you're going to make that kind of investment. So mathematicians usually look at these kind of problems, no matter how complex they are, and they're going to break it down in terms of joint probability distributions and algebraic objects. And they're going to be huge matrices and tensors. The fun part is with deep learning, the stuff is already joint probabilities and tensors.
It's already there.
So, I think that this whole phase of having mathematicians come in, it's going to get interesting. The first one that I'd really point out to out of Chicago, there's a project called Weight Watcher. And so Charles Martin, they've taken and they're using statistical mechanics to analyze existing models to find out which parts are working or not. Might give you some indication of all that money you spent training the model, what part was actually useful.
And are you talking about what parts of the model are contributing the most to the functionality?
Yeah, at inference time. What is, after you've trained it, exactly what parts of the model do or don't. And it's a really complex problem because deep learning still sort of defies some of the measures that we had for machine learning before. Some of the metrics that we had from measuring supervised learning before, it doesn't all hold up. And we're, the experts, I will not claim to be an expert in this field, but ideas of memoization are still kind of being debated. Right. What's really going on? So the ability to have really intense mathematical tools to understand these models are important because, by the way, companies are spending hundreds of millions of dollars to train the models. But I think it goes much deeper. So there's a couple areas that I'll point to. One is I really like this work out of Purdue, David Gleich and some of his grad students. They've been looking at using topological data analysis, but in particular graph TDA. And the idea is to be able to go in and understand for data that's being used to train a model, how can I understand maybe parts of the data that need to be finessed first? So here we're applying analytic tools to understand the data that will go into training the models.
And when you say finesse first, you mean go into the data set and figure out which parts of the data are actually meaningful, that are contributing to the results that are in the direction we want to go, and which might be either less helpful or even contradictory.
Yeah. And I mean, if we roll the clock back a decade and we had models that were trained on like 5,000 rows, I mean, you can do that, right? Yeah.
Right.
That's what, I mean, maybe it gets complex and use a random forest or something, you could do it.
Right.
And now if we're talking about, trillions of tokens being going in, and you can't do that.
Good luck.
Unless you have the tooling.
Right.
So there's that level of tooling coming in and giving us more mathematical methods to go in and fix up the data, which I think that's always where the ROI is going to be. More so than, say, fixing up the algorithms. And so that's one part of it. We've definitely seen some evidence of this since about December. If you look at the activity on the Hugging Face leaderboards, there's been this thing, a lot of work. General umbrella would say reinforcement learning with human feedback, so RLHF. But there are different variants of this, like DPO was really popular, great paper behind that, TKO, spin, on and on and on. There's different variants being evaluated. Long and short, somebody will spend millions and millions of dollars to train a model. They get up on the leaderboard. And we've seen this with Zephyr and others, right?
Mm-hmm.
Other groups will come in, look at the data, analyze it, do some direct preference optimization or whatever, fix up the data. And then suddenly, without spending all the money on all the GPUs, they've leapfrogged the original on the leaderboard. Yep. And I think that, we've seen this over and over with Hugging Face, Nargila, I know Snorkel is in on this and others. We've seen this since December. It's been a lot of the activity. I think that we're going to see this in industry where somebody goes and pays an obscene amount of money to build a model and other people come along and go, thank you. So that's going to be fun. But there's another side of it, of where hardware meets in the middle.
Yeah.
So, the other thing that's going on is when you look, I've broken it down and we can publish some of this if you want, but, you look at everything happening with NVIDIA, of course, incredible. Intel, also huge spend trying to catch up, and a lot of interesting work there. I think they've done really well to boost up the ecosystem for startups, especially building the tech stack around their offerings.
Right.
But then AMD has not been quiet, and I think that AMD is really, really caught up. I would actually say watch AMD. That's kind of my view. Okay. But, you've got other players in there. Broadcom, I mean, there are these other partnerships that Google goes to Broadcom to get their chips made, and Amazon goes to AMD and others, and ARM. I think Amazon has like 5 AI chips right now.
It's something like that, right?
And it's a serious spend.
Oh, yeah.
So what I'm saying is everybody's chasing after this mythical AI chip, but I believe that what we're really going to see is a lot of windfall on the hardware side, because when we do application in industry, a chatbot is not necessarily the deliverable. Right?
No.
A lot of the AI use cases in industry, really the last mile is more about decision support. So we do a lot of work to get the data in shape so that then we can have a convex optimization or a dynamic programming model or like a causal inference model at the end, because execs need to make decisions about where to place their bets.
Right.
And they need contingencies and they need to understand it. So they need decision support that is not necessarily machine learning. A lot of the more advanced areas of this end up with solvers, with things that are really expensive to run because of the hardware. But now we're seeing all this capital investment, billions flowing into better and better hardware price point, which can be reused for decision support. So I think that we will see windfalls, and I think it will be in areas like causal graph, areas like I said, convex optimization, stuff that used to be the domain of, say, AT&T and DoD when I was in grad school. They were like the only people who could really do the thing we were learning in school with operations research. But now you're going to see more of that kind of advanced decision support filtering out into the mom and pop shops who are leveraging LLMs.
Oh, that's fascinating. See, I did not expect you to say that. So your thought is that this huge amount of investment that is going into what, for the most part, would be sort of deep learning focused hardware, there are going to be these trickle down effects that people aren't even aware of right now.
Yeah, I mean, case in point, there was just GTC. Jensen Huang got up and gave the keynote for NVIDIA, and they were showing off, the latest chip that they have is this enormous die. It's 2 different chips on a single die, and then there's an insane connectivity problem between them. And this idea of having these like really large wafer scale things that have, huge amounts of acceleration on that connectivity we haven't really seen that for commodity hardware before. I don't know that, chips that cost more than any of my cars ever do. I don't know that that's necessarily commodity, but we'll see it there.
Right.
And so I think that there's been a lot of emphasis, and what I hear on the hardware side over and over, connectivity, that is the issue. Getting a lot of independent parts to work together synchronously. Right. And we're seeing some breakthroughs on the hardware side. It's really more production, but the fact is so many billions have gone in, and hardware is an extremely capital intensive, demand driven kind of thing.
Oh yeah. There are trillions flowing into it right now. What do you think is just kind of overhyped right now? Just too much attention. Maybe not that it's a dead end or anything, but just too much hype.
Yeah. So I mean, you talk to some of these groups. I've been in neural networks. I took an interest in neural networks in about 84. And I did some work with neural networks when I was at Bell Labs. I was at John Hopfield's lab for 5 seconds.
Wow, you were Hopfield's lab.
I didn't know the reorgs hit.
I didn't know that. Oh, wow. Okay.
I begged and screamed and pleaded and got into Hopfield's team.
Wow.
But then the reorgs hit, and they had me going and doing X25 adapters, and it was like a total shift. But then I came here to Austin for Motorola. I was software lead on the Motorola neural network hardware accelerator project. So that's what got me to Austin.
Okay.
Years and years ago. So I've gone down the neural network side, but I've also been interested in the symbolic inference side as well.
Okay.
And I think there's a lot going on in between those. You still talk to some of the shops, and they are just like, everything in the world is our flavor of neural network. We can model the entirety of existence with our flavor of neural network. Mm-hmm. I won't throw any names, Meta, but there are definitely some that drink their own Kool-Aid, and it's great. They do great work. But I believe there's more, certainly when you look at the physiology of animal brains, there's a lot more going on than just the neocortical structures that we're trying to model with deep learning.
Right.
There are games that animal brains play with shifting time and foreshadowing so that we can go out and run, so that we can, throw spears and catch prey. You could not do that if your processing was all just following deep learning.
Right. All right. Just to set the table for our listeners, you're talking about all the hotness right now, deep learning, neural network-based, artificial intelligence focused. There's a whole nother world out there that for decades, intermittently was the dominant approach within artificial intelligence research, which is symbolic AI. It's kind of fallen off the scene a little bit, and you're saying you think that that's unfortunate. And there's really a chance for hybrid systems, or are you betting on symbolic alone?
Well, it's interesting because there's a periodicity of about 10 years. Yeah. The pendulum swings back and forth.
Right.
There's this weird periodicity between Stanford and Berkeley. I'm in the Bay Area. But you see a 5-year pendulum where the Berkeley people have a startup, they'll make a lot of money, Databricks gets launched, everybody quits doing research, and now they're in a startup. Mm-hmm. The other side of the Bay, they're like, damn, we missed out. We double down, we do a startup, it gets hot. Berkeley side is like, oh man, we missed out. So there's a 5-year thing in the Bay Area that keeps driving it. But in AI in general, there's a 10-year between the statistical AI and the symbolic AI side. And what we're seeing now, though, is more hybrid. Neurosymbolic is the academic term. I'm not sure. I mean, neurosymbolic, I guess it's descriptive. Hybrid is probably maybe a little more business friendly. But yeah, so right now, rather than just taking and just going purely data-driven, we're going to throw trillions of tokens in and then magic will happen. We may not understand why our large model is working, but it's working good enough. So
close enough.
I don't buy that. I think that we'll see much more of a deconstruction of RAG going forward and see more and more touch points of where the symbolic comes in. We were talking before a little bit about in the neurosymbolic area, one example to look toward are things like semantic loss functions. So when you go and train on your trillions of tokens, mm-hmm. are you using a knowledge graph for training your loss function? Because then you're cutting the chase. Then you're propagating conceptual symbolic signals down.
Oh, that's fascinating. So let me deconstruct that a little bit.
Yeah.
So you're talking about, instead of just having some type of closed form loss function that doesn't have any sort of semantic understanding associated with it.
I mean, it's good. Some self-supervised learning. Great.
Right.
You can do a lot.
Right. Okay. That's fascinating. Okay. All right, I want to stick with this thread a little bit. What else do you think is just under the radar too much these days?
Yeah, I do think that, I mean, there's a lot you can do with LLMs. They're really good in like syntax, understanding languages. Yeah. And I think that the more that we start to understand how we use languages, especially purpose-built, I've done a little bit of work in like legal applications, and, there's a whole other language of how legal apps are codifying language. Mm-hmm. But yet, doing work over in, say, big data and functional programming, we have something called DSLs. We have something called domain-specific languages. Right. And those were, all the rage maybe a decade ago.
Yeah, they were.
But, I mean, there's some really great libraries in Python and Scala and other languages like that, too. So what I'm thinking is, as we see more and more of like the software engineering people start to come into AI,
right?
We're seeing more calls for, well, why don't we try to constrain this problem? This use case, let's write a DSL for it, right. And then we can fine tune our large language model on that DSL. Now you've got a copilot for your use case.
Yeah, and just to be a little bit more concrete on that for folks who might not have familiarity with domain-specific languages, this is an approach where you can essentially sort of limit the grammar, limit the output of your language model, so you constrain it, and it literally is sticking with, let's say, a programming language. It literally cannot output nonsensical or ill-formed programs.
So testing becomes a lot more straightforward.
Yeah.
There's a lot. I mean, the whole point of like AI safety and guardrails and all that, it becomes a lot more sane.
Right. Let's go back to the areas of things going in AI that you're interested in particular, that most people just aren't paying attention to.
One area that I've been tracking for a while that I think is just fascinating is data governance. And it has so much bearing on AI. It's really a major driver, and in ways that I think a lot of people miss. So, you roll the clock back, you look at like mainframe era. You had a big, huge server, big iron, and a bunch of terminals connected through wires. Yeah, right. Okay, it's a fairly simple topology. Governance was there, but it was like how you logged into the mainframe. Right. Basically it. And then you roll out a little bit further, you get like, Sun and others. You had client-server architecture, and you had Oracle or whatever. You had some sort of database back there. There's governance is starting to trickle in, probably more on the data side.
Right.
And then you progress a little bit further. We get into the 90s. We had like 3-tier architecture for e-commerce. Yep. So you had that middleware, but you also had the browsers. You had a lot more touch points, a lot more security concerns. There's a lot more potential surface for cyber attacks. There was a lot more sophisticated governance that was evolving, and there's a lot more data being captured about that. But then you get out to this crucial period in like 97, 98, and the big players in e-commerce were realizing, they had a big box and they were serving a lot of people off their website. And at some point, this is a really strange little economic formula, but basically, if you invest in transactional systems and you get more customers, you get more revenue. So there's a linear relationship. In analytics, though, it isn't linear, because in effect, it actually goes sideways. The problem with analytics is if I have 1,000 log files describing the behavior of a web app and it's behaving correctly, if I add another 1,000, I don't get 1,000. I don't double my revenue.
Right.
I do double my cost.
Right.
And at some point, because you've got diminishing returns in the analytics ROI, but you still got this linear ramp on the infrastructure cost, you get upside down. Mm-hmm. And so, unless you can actually use that data for something valuable, the analytics, you get this negative growth. You get this negative ROI in growth. So an interesting thing happened back in the late 90s. The big players then, Amazon, eBay, Inktomi became Yahoo Search. Google was just starting out, but they were realizing this too. Everybody came to the conclusion about the same time. It's like Oracle's going to eat our lunch. We're taking log files and we're dumping them into transaction systems. We have to pay for bigger and bigger licenses, and we aren't going to be profitable. So in Q3 of 97, Greg Linden and the team at Amazon, they've written about how they went through this big effort to split the website. They took their one web app running on one server with one big Oracle database, and they split it into 4 servers.
So advanced.
Yeah, I know. It's crazy. And Randy Shoup over at eBay, they did a similar thing. They took their one big Windows NT box and they had 4 of them. But that was the start of cloud. because now you could take and like scale out in parallel on a server farm. The one problem though is like, what if there's a cyber attack? You have to trace it. What if there's a lawsuit? What if there's some sort of problem you're tracing? You got to have log files. Mm-hmm. And so when you start to have this like server grid, now you start to have a storage grid for all the log files. You know, the data product owners, no, sorry, step back. The product managers, let's call them that first. Back at the time, they started looking at things like this and going, well, let's do some A/B testing on our features because we got these log files. So now we can check statistically, is this feature getting better traction than this other feature? Once you start doing that, it's the thin edge of the wedge for data products. And DJ Patil and others have talked a lot about their ideas back then that, you know, once you start doing A/B testing, you realize, wow, I'm doing some data mining on my log files. I've got a data product. Let's build a recommender system. And now the recommender system is using machine learning to inject more powerful features in e-commerce. You get a virtual cycle. Right. You get more features, more usage, more log files so that I can work harder to buy more cocaine to, you know, that kind of thing. But you get this virtual cycle that emerged and, you know, people like Leo Bremen and others wrote about it in about 2001, where it was a real break where you start to see this weird virtual cycle emerging, machine learning using data products. And that kind of gets back to the point of like, I don't want my analytics data costs to go sideways. I can actually build a data product and get value out of it. And then we roll the clock up, you know, later next decade, we saw mobile and then we see multi-cloud and we see compliance coming in, GDPR and others, European. And so you have a lot more evolution of the topology of these heterogeneous networks and what's going on. So you have a lot more surfaces for attack. You have a lot more reasons to be able to track them. You also have a lot more governance to be accountable to.
That's right.
And you get a lot more data products flying around the enterprise as a result. And you start getting AI applications that are leveraging these. Right. And so that's kind of where we are now. So I see data governance as a really important thing. Compliance, I work a lot in Europe. You know, GDPR has been a godsend for tech startups in Europe. And it saddens me that is not the view in the US, but it definitely, yeah, maybe a little bit different kinds of governance there. But definitely, I think that the data governance and compliance issues over in the AI space are drivers for the evolution of AI. And I don't think that that's really given enough oxygen.
We had an executive roundtable last week, and it was one of the number one topics. AI, data governance. Everybody there, every CTO, every CIO, every CEO at the table is very, very concerned about it because, you know, everybody's reaction last year when ChatGPT broke, well, not everybody's, but a lot of their reactions were just block it at the firewall, right? Yeah, and like that's not a long-term answer. Right. Yeah. So I think it's a huge area of importance going forward. All right, let's shift a little bit. Paco, I want to hear your thoughts. Where do you think? Let's do a little future prediction. Where do you think AI is going to go in the next 5 years? And then I'm gonna push you a little bit,
okay.
and I'm going to ask you to kind of like look out about 10 years. But like, what do you think the things are going to happen in the next 5 years? Whether they're broadly accepted, or you know, you could throw some surprises at us.
Wow. Okay. So 5 years out, I do think that like the kind of hardware windfall scenario that we're talking about, that's one of the issues. So there's definitely this kind of latency because it takes trillions of dollars to change the hardware industry. Yeah. But once it changes, you can really, you know, pump it out. So I think that we'll see price points coming down on really sophisticated hardware, and we'll see more and more like low power kinds of cases of fairly sophisticated hardware.
Yeah, like more. Yeah, and that'll definitely push things out to the edge even more. Yeah. Right.
Inference on the edge. I have friends, I'll do a shout out to a few friends at a company called Useful Sensors. Okay. So Pete Warden and company, basically some of the people that built TensorFlow and were evangelizing AI inside of Google. After a while, after about 8 years, they went off on their own, and they've got a little company, and they're really focusing on like AI on the edge. Mind you, these were people who built built TensorFlow. Some of them in previous life built a little thing called CUDA. I don't know if you ever heard of it, but they know what they're doing.
A little bit, yeah.
And I, listening to them, I mean, a lot of the things that they struggle with are, again, the connectivity issues.
Yeah.
That on the inference side, it's not a compute power thing, it's a connectivity thing.
Right.
And so I think that we'll see a lot more of the hardware work, really interesting, juicing up the edge. I also think that there's inherent latency for some of the advanced topics in AI that have been researchy but haven't seen light of day. There's a period of maybe 7 to 8 years. So if we say 5 years out from now, 2024, then I can roll back to like, what was going on in 2021? Because the stuff that was like, PhDs in 2021, you'll probably see as industry use cases 5 years from now. And we see shadows of this already, or foreshadowing of it. The other thing is just that, it's a 5 year latency. Like I have friends working in pharma, and, they can say that they've made a breakthrough and they're really super excited about cancer drugs.
Right.
They can't tell us anymore. It's going to be another 5 years before it comes out of the pipe. Right. So I think windfalls of AI and drug discovery, I think we'll see a lot of that.
What about AGI? I was talking to one of the founders of DeepMind during South by Southwest, and he was very bullish. In fact, he said he would bet 5 years.
I think there's some problems. And this is where I'm going to come back to saying, I love what DeepMind is doing, and out of all the properties out of Alphabet, I think that they're incredible. And have had a number of friends go through there. I think that AGI is a really slippery topic. It can mean whatever you want it to mean.
I totally agree.
And so I'm not going to sign up for that. I do think that the neurophysiologists have a pretty good clue about what our requirements list is. And there aren't too many surprises. And some of that is much further down the pipe.
Okay. All right. So you're thinking we're a bit away.
Yeah. It's a bit like self-driving cars. I mean, I have a friend who takes people on interviews by getting a Waymo and then go up and down hills. You can do that in a constrained environment, but generally speaking, self-driving cars are
that long tail is just going to be, it's going to be a nightmare to knock out. Yeah. Okay. Anything else you want to share? Any other thoughts about the future?
Well, I love the math side of this, and I just think that that's where some of the most interesting parts of this are. And
by that you mean getting a much deeper, richer understanding of how these complex systems actually work.
What's going on, in contrast to, say, chat. I mean, I love chat. I had a bookstore here in Austin years ago called Fringeware. We had a chat bot in like 95 for our e-commerce catalog. We had a lot of fun playing on that. We found out something, and I mean, I was doing NLP chat work back at Stanford a decade before. Chat is this really elusive interface. It looks like it's super powerful. There's a lot of gotchas. And again, it's that long tail. And you start chasing the gotchas, and then you realize, oh my God, look how much this is going to cost to do it. And I certainly think that projects like Alexa and others are at the oh my God stage right now.
Yeah.
So I don't put a lot of credence into chat taking over the world. I mean, the way that I would play this out is, I think that in 2023, speaking as a consultant, a lot of executives were out playing with ChatGPT and sort of daydreaming publicly about how, what if I just laid off half my workforce? I can ask the magic 8-ball to give me the answer to how to optimize my business. We'll become super wealthy.
Right.
But it's like if, 20,000 other MBAs have that same exact idea, and they're all asking, just optimize my business. It's a race to the bottom, right? It's random noise. Yeah. And so I think that this idea of like, just get a magic black box and make it souped up and it'll solve all our problems. I mean, that's a pipe dream. And I think people are waking up from it now.
All right, Paco, that was fantastic. I really appreciate that. Just kind of riffing from topic to topic. That couldn't have been more fun. Thank you so much for coming back on.
Thank you, Ron. I really appreciate it.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.